So good day everyone. Today we will be discussing about enzymes. So here are some of the objectives for today's lecture. We want to have an introduction to enzymes and their roles in the cells of our body. We want to discuss the different classes of enzymes and their actions that they speed up, to learn about the different models of enzyme action and the factors that affect enzyme activity, to learn about the different ways enzymes are inhibited and controlled or regulated, and to discuss the different medical uses of enzymes and their inhibitors. So let's jump right into what enzymes are. So enzymes are catalysts for biochemical reactions. So what are catalysts? So ito na yung definition ng catalyst as derived from one of the dictionaries I found online. No? So your catalyst is a substance that enables a chemical reaction to proceed at a usually faster rate or under different conditions than otherwise possible. So if you have a reaction that is occurring at the normal pace, so kunyari, the normal rate, so ito yung, I like this image. This image is from Marx, another biochemistry book. So maganda yung pagkaka-visualize niya on how to visualize kung ano yung ginagawa ng enzyme natin sa reaction. For example, this is a room, at yung isang bilog na yan is a golf ball. So if you have a reaction proceeding in this room, ang example niya, for example, is this area, itong kulay blue, is the total amount of product or total amount of golf balls produced in that room for 1 year. So, for example, this is the first image. Every year, meron siyang pinoproduce na 100 golf balls. So, yun yung normal rate of reaction niya if you don't put an enzyme or a catalyst. Pero, once you put an enzyme or a catalyst, the reaction speeds up immensely. So, ang nangyari, if you put an enzyme inside this room, ang nangyari ngayon is you get a room full of golf balls after only 1 second, di ba? So, sobrang laki ng effect niya as far as speeding up the reaction is concerned. So, from making only 100 golf balls in a year, you can make a room full of golf balls in 1 second. So, ganun kalaki yung effect ng enzymes sa reaction. So, instead of a reaction taking up a whole year, before it proceeds, your reaction can happen in seconds. So how do these catalysts allow the reactions to proceed so quickly? It does so by lowering the activation energy of a reaction. Kasi before a reaction can proceed, kailangan siyang mag-accumulate ng a certain amount of potential energy. And once they reach that level, or yung tinatawag nating activation energy, then the reaction can proceed. So, hanggang di na-accumulate yung required amount of activation energy, hindi magpo-proceed yung reaction. So, what the enzymes do, what enzymes do is it lowers the required activation energy. So, for example, so ito yung so here is a visualization of what the activation energy is. For example, di ba, nag-accumulate yung reactants mo ng potential energy. It has to reach this much para mag-proceed siya in a normal state kung walang enzyme. Pero if merong enzyme, what the enzyme does is it lowers the needed activation energy para makapag-proceed agad yung reaction, para mangyari siya agad at para maging mas mabilis siya. So, another characteristic of your enzymes is that it is not consumed during the reaction. So, kapag meron kang enzyme, tapos nagawa niya na yung task niya, hindi siya masasama sa product, hindi siya madedegrade, it's not consumed. Nandun pa rin siya kung nasan siya after the substrate has binded, the reaction has occurred, and the product has been released. Nandun pa rin yung enzyme as an unchanged substance. Next, your enzymes are usually made up of globular proteins. So, yung enzymes, as mentioned, are the catalysts or the biochemical catalysts found in our body. So, and in our body, they're usually made up of proteins. We just have some exemptions that are nucleic acids, pero the vast majority of the enzymes found in our body are proteins. So let's go into the basic structure of our enzyme. Let's have some definition of terms para magkakaintindihan tayo pag nagsabi tayo ng certain terms during the course of our lecture. So the first one is your substrate. So the substrate is the substance on which an enzyme acts. So meron kang reactant mo, then the enzyme will act on the reactant in order to produce what you call the product. So the product is a substance produced by the reaction, by the action of the enzyme on the substrate. So enzyme plus substrate equals product. Next. So, another thing another two terms that we'll discuss is regarding the uh, structure for enzyme. No? So, we have what you call your active site. So, what is the active site? The active site is a region or domain where the substrate binds. So, yung active site na yun yung certain part where the substrate goes. So, parang sa bibig ni Pacman, di ba? Yung loob ng bibig ni Pacman. So, yun dun nagbabind yung substrate. So, for example, here is a substrate. And here, the active site here is this one in blue. So, yun yung active site mo, yung kulay blue. So, your substrate can bind to the active site in order for the reaction to proceed. Okay? So, your substrate will form bonds with amino acid residues found in the binding site, di ba? And then the substrate binding will induce a conformational change. And that will allow further binding. And then uh, and then uh, the reaction will proceed. And then later on, after the reaction has happened, then the products will dissociate from the enzyme, and the enzyme will return to its original state. Kasi nga sabi natin, your enzymes are not consumed in a chemical reaction. So, next, ano naman yung cofactor? So, the cofactor is a non-protein component that assists in the catalysis of your enzymes. So, meron tayong cofactors. They are, nagdadagdag sila ng additional bonds para maging mas maganda yung binding between the substrate and the enzyme. So once your substrate has bonded to your enzyme, you call that an enzyme substrate complex, diba? So, your enzyme substrate complex is an intermediate reaction species that is formed when they bind to each other. When your enzyme substrate complex is formed, yun na yung that allows better conditions for the reaction to occur than if the reaction were to occur unbonded, no? So, and then there will be faster formation of the product. The product will then dissociate and the enzyme will return to its original form. Kaya sabi nga natin, your enzymes are not consumed in a chemical reaction. Okay? Next. So, there are two types of enzymes. Meron tayong simple enzymes and then you have your conjugated enzymes. So, binanggit ko na kanina yung may cofactor. So, that's a conjugated enzyme. But we also have your simple enzymes which are composed entirely of amino acid chains or protein. Then, we also have your conjugated enzymes. Yung sinabi natin, merong protein and non-protein part. Pag may non-protein part, you call that non-protein part as a cofactor. So, the protein part in a conjugated enzyme, you call that a apo enzyme. The non-protein part in a conjugated enzyme, you call that a cofactor. So, apo enzyme plus cofactor, you form the holo enzyme. So, the holo enzyme, holo is in whole. Okay? So, apo enzyme, protein, cofactor, non-protein. So, and then, you put them together, you come up with your holo enzyme or your whole enzyme. So, it's the biochemically active conjugated enzymes. Okay? Next, yung cofactor naman natin, there are two different types. So, your cofactors, as mentioned earlier, provide additional chemically reactive functional groups to allow better binding of your substrate to your active site. So, your cofactors may be temporarily or permanently bound to your apo enzymes. So, there are two types. Meron tayong coenzymes at meron tayong metal ions. Your coenzymes are small organic molecules and they're usually derived from your vitamins. Meanwhile, you have your metal ions which are such as zinc, magnesium, ferrous and ferric ions, and then cupric and cuprous ions, which are usually derived from your minerals. So, yung vitamins and minerals natin are very important for enzyme function in our body. Kaya nga dapat umiinom tayo ng vitamins kasi your enzymes, kasi wala mag-speed up ng mga chemical reactions in our body kung we don't have enough vitamins. Okay? So, next. So, doon na tayo sa nomenclature on how enzymes are named. So, how are enzymes named? Of course, sabi natin, if it ends in an ASE, Then ase, it's probably an enzyme. So the suffix ase indicates that the substance is an enzyme. Some of the enzymes also still end in dash in, di ba? Si pepsin, si trypsin. So here are some examples. So si urease, lactate dehydrogenase, your pepsin, your trypsin, your lipase, amylase. Yun yung possible suffixes for in order that indicates that your substance is an enzyme. So next, the prefix may indicate the type of reaction. So depende sa reaction, magbabago yung pangyayari, no? Magbabago yung pangalan niya, no? Rather. So for example, if it's hydrolysis reaction and then it's a hydrolase kasi enzyme siya. So, hydrolase. For oxidation, is an oxidase. For reduction, it's reductase. It's for group transfer, it's transferase. So, may maganda sa enzymes kasi, hindi siya yung memorize ka pa ng ether, whatever. Hindi ka kaya sa mga functional groups, no? Dito kasi, maganda sa enzymes is, you have an idea of what the enzyme is doing based on nomenclature. So, madali lang siyang tandaan. Okay. Next. In addition to or in lieu of the type of reaction that occurs, the identity of the substrate may be noted by the name of the enzyme. So for example, here are some examples of the of this statement, no? So for example, di ba ito si pyruvate carboxylase. So it's the carboxylation reaction of a pyruvate molecule. You have an oxidation of a glucose molecule. Or, pwede namang, if hindi siya inad, pwede namang, rather than the type of reaction, it will indicate the substrate. So, ito, hindi naman nakalagay yung type of reaction, but you have your urease and then your lactase. So, itong dalawang to, these two are hydrolysis reactions, pero hindi na nilagay yung hydrolase siya, no? Diretso na siya doon sa specific substrate. So, urease and then lactase. Okay? Next. Let's go now to the modes of enzyme actions. So, yung models of enzyme action, it will just give you an idea of how your enzymes work and how they fit. So, ito yung sinabi natin kanina, yung active site and then the enzyme substrate complex. So, the active site is the small portion of the enzyme that actually participates in the interaction. So, it's usually a crevice-like location in the enzyme. So, crevice, di ba, parang siyang hukay, tapos, or uka, and then that's where the substrate. So, parang siyang puzzle piece. Yung puzzle piece mo, yung isang end niya, siya yung pumapasok dun sa notch ng enzyme mo, that where it fits. Okay? So, and then you have your enzyme substrate complex that allows the substrate to encounter more favorable binding conditions. So, review lang yun nung sa sinabi natin kanina. So, let's go now to the two models that they believe applies to your enzymes. You have your lock and key model, and then you have your induced fit model. So what is your lock and key model? In your lock and key model, you believe that the enzyme has the substrate fits into your enzyme akin to a key and its lock. So kung meron kang susi, tapos yung susi na yun, di ba? It fits inside the padlock. So kailangan saktong-sakto, otherwise hindi siya bubukas or hindi ka makakapasok sa loob ng kwarto. So lock and key model. So in the lock and key model, they believe that your substrate and enzyme are complementary to each other and that the active site has a fixed rigid geometric conformation. So rigid yung conformation niya, and in order for for a substrate to be acted upon by the enzyme, kailangan yung substrate mo ay saktong-sakto dun sa active site ng enzyme natin. And then only substrates with complementary geometry can be accommodated by the active site. So kung for example, ito bigla hindi siya saktong-sakto dito, then the reaction will not occur. So yun yung idea sa lock and key. Kailangan akin to a lock and its key, dapat saktong-sakto sila sa isa't isa. Otherwise, hindi siya mangyayari. Hindi siya bubukas. Okay? Next. Dito naman tayo sa induced fit model. So, itong induced fit model, ito actually yung mas accepted theory on how enzymes work. So, in the induced fit model, the enzyme has enough flexibility to allow for small changes. So, kailangan similar enough, pero hindi naman siya kailangan na saktong-sakto. So the flexibility of your enzyme allows the active site to change its shape. So, yung active site mo, it will change its shape in order to accommodate the substrate. So, for example, itong si substrate mo, pumasok siya dito sa active site. So, as you can see, hindi naman siya saktong-sakto doon sa active site nitong enzyme na to. But because this is induced fit model, what your enzyme does is it actually modifies itself in such a way that it is able to accommodate the substrate. Kaya, so dito, si enzyme ang nag-a-adjust. So, dito, si enzyme, kapag nakita niya si substrate, hindi sakto, then, hindi na mangyayari yung enzyme. Hindi na mangyayari yung reaction. Kailangan saktong-sakto siya in order to come up with your products. Meanwhile, dito, pag pumasok siya, tapos hindi naman siya saktong-sakto, pero pwede na, then, hindi naman yung sobrang layo doon. So, syempre, pag sobrang layo, hindi naman na yun tatanggapin ng enzyme mo. So, dito, if it's close enough, then, accept na rin yun ng enzyme mo. And yung enzyme na yung mag-a-adjust. So, pag nag-adjust yung enzyme, then, the reaction will proceed. Okay? Next. So, you have your lock and key, and then your induced fit models. So, meron tayo nung tinatawag nating different levels of specificity or so yung enzyme specificity. So, the enzyme specificity is the extent to which an enzyme's activity is restricted to specific substrates. So, paki-erase yung A dyan. So, type lang yan. So enzymes may exhibit selectivity for certain substrates, no? So, meron tayong absolute, meron tayong group, meron tayong linkage, at meron tayong stereochemical specificity. So, the degree of specificity is determined by the active site. So, syempre, di ba sabi nga natin, pwede. So, depende kung gaano kalaki yung accommodation ng active site natin, kung gaano siya ka-accommodating, syempre. Kung hindi siya gaano accommodating, syempre, it will not, it won't, kung hindi siya gaano accommodating, then, it will be a very specific enzyme. Pero kung hindi naman, syempre, kung very accommodating siya, syempre, mas less specific siya compared to other enzymes. So, meron tayong tinatawag natin absolute specificity. Ito yung pinaka-specific sa lahat. So, this is the most restrictive, and it's also not very common. So, it's an enzyme that catalyzes only one reaction. So, an example of that enzyme is your catalase. So tandaan nyo lang yung mga example. So, next, then you have your group specificity. So, what is group specificity? The enzyme acts only on molecules with a specific functional group. So, pag nakita niyo yung functional group na yun, then the enzyme will be able to act on that enzyme. So, for example, is a carboxypeptidase. So, carboxypeptidase is group specific. It will cleave your amino acids one at a time and from the carboxyl end of a peptide chain. Okay? Next, you have your linkage specificity. So, your linkage specificity naman will act only on a specific linkage or chemical bond. So, linkage specific, it looks for a specific bond. Si group specific, it looks for a specific functional group. Okay? So, linkage specific, it looks for a respective bond for a specific bond. An example of which is your phosphatase. So, phosphatases, hydrolyzed phosphate esters. So, you will encounter phosphate esters later on, lalo na pag nandun na tayo sa nucleic acids. So, next, you have your stereochemical specificity. So, stereochemical specificity, yung mga stereochemically specific enzymes natin are enzymes that act only on particular stereoisomers. So, di ba, sabi nga natin, yung mga proteins natin are usually, your amino acids natin are usually chiral, hence our proteins are, so, yung mga amino acids are chiral, so, syempre, yung mga active site natin, meron din chiral, may chirality din yun. So, yung mga enzymes natin, meron din silang chirality. So, specific sila kung L-type lang ng amino acid yung nagkakatabi sila or D type lang, no? I mean, D form rather of an amino acid lang yung ikakatalyze nila. Kung gusto nila, level lang, yung mga level lang yung ikakatalyze nila, etc. So, ganun yung stereochemical specificity. So, now let's go to the different classes of your enzymes. So, meron tayong several types according to IUPAC. So, the first class of your enzyme, class 1 is oxidoreductase. So, oxidoreductase catalyzes an oxidation reaction or redox reaction. So, alam ko naman, asumang na kayo sa redox. Pero, recall lang natin yung redox in bio as far as orgchem is concerned, di ba? So, if you have a redox, then there is an increase in, there is loss of electrons. So if you have a loss of electrons or oxidation reaction, there's an increase in the number of CO bonds or a decrease in the number of CH bonds. If you have a reduction reaction, or there's gain of electrons or a decrease in the number of CO bonds and an increase in the number of CH bonds. So your oxidoreductase, so magkasama nila. So, pwedeng oxidation, pwedeng reduction. It can be any of these. Pwedeng magkahiwalay. Okay. So, it requires a coenzyme that is oxidized or reduced as the substrate is reduced or oxidized. So, for example, here, you have your lactate dehydrogenase. Kailangan meron kang coenzyme in this reaction kasi magka-partner nga nangyayari yung oxidation and reduction natin. So, if you have your reduced substrate here, kailangan meron kang ma-oxidize. And that is the coenzyme. So, ang nangyayari dito, sabi natin, so meron tayong tatlong types pala ng oxidoreductases, no? You have your oxidases, you have your reductases, and then your dehydrogenases. So, ang nangyayari dito sa oxidases, syempre, there is oxidation. In reductases, syempre, there is reduction. And then you have your dehydrogenases. So, nangyayari sa dehydrogenases, there is removal of 2 H atoms. Therefore, you introduce a double bond. So, ganun yung nangyayari sa dehydrogenases. So, di ba, sabi natin, so, ganito yung example ng oxidoreductase reaction natin. So, if you look at your, so, ang tatandaan mo actually, hindi mo kailangan tandaan yung reaction totally. Kasi hindi naman natin hindi naman kayo pagtitingnan ng specific reaction, tapos identify the type of reaction. Hindi naman natin gagawin yan. Masyado na yung toxic. So, what we will do is we will look at this type of, ito yung actually tatandaan nyo dyan. Ito yung high yield dyan. So, okay? So, here, this one. And yung specific happenings for each substrate, for each type of enzymes, di ba? So, kung oxidase, it will catalyze oxidation. Reductase, it will catalyze reduction. Dehydrogenase will catalyze removal of hydrogen atoms. So, kailangan matandaan na these three suffixes, kasi di ba usually siya yung last name ng enzymes natin, yung type of reaction niya. Di ba sa enzyme nomenclature, yung function, yung enzyme, kasama siya sa enzyme nomenclature. So, makikita mo dun sa nomenclature na yun, kung ano yung reaction it catalyzes. So, you want to know the reaction and under what classification siya nagbe-belong. So, oxidases, reductases, and dehydrogenases fall under oxidoreductases. So, ano nangyari dito sa reaction na to? So, discuss na lang din natin, di ba? You have dehydrogenase. So, dehydrogenase, you have removed 2 hydrogen atoms. So, nagkaroon ka ng 2 hydrogen atom. Yung isa, napunta kay NAD. Yung isa, naging free hydrogen. Kasi di ba sabi natin, 1 hydrogen is accepted by the coenzyme. So, yung coenzyme mo will become reduced. Kasi nadagdagan siya ng hydrogen. Okay? So, ang nangyari dito, dahil nawala yung H dito and nabawasan to, you introduce a double bond between your C and your O. Kaya nagkaroon ka ng C double bond O. So, yun yung nangyayari in dehydrogenases. You introduce a double bond because you remove the H's on both ends. Okay? Next. Let's go to another class, yung ating transferases. So, your transferases, as obvious by the name naman, no, it catalyzes the transfer of a functional group from one molecule to another. So, here are some common transferases that we will encounter: your transaminases and then your kinases. So, your transaminases transfers an amino group, while your kinases transfers your phosphate group. So, for example, dito, no, you have your hexokinase or hexokinase. So, hexo is a hexose, and then kinase, it's a transfer of a phosphate group. So, sabi natin, itong ATP, di ba, tatlo yung phosphate niya. So, ano nangyari dito? One of the P's will transfer to your glucose on the 6th carbon. So, magiging glucose 6-phosphate kasi dito kumabit yung phosphate, and then this becomes ADP. So, yung isang P dun sa ATP will transfer to the 6th carbon. So, excuse me. So, yun yung example ng kinase, di ba? Si hexokinase catalyzes the transfer of a phosphate group from an ATP molecule to your glucose 6-phosphate. So bakit kinases? Paano nyo tatandaan? Kasi, di ba? So tandaan nyo, si kinases transfers your phosphate, and then your transamine, it transfers aminases. Okay? Next. So, itong si transaminases, you can also call them amino transferases. So, mas madaling pero mas modern na yung pagtawag sa kanila as transaminases. Okay? Next. The third class is your hydrolases. So, hydrolase, as the name implies, hydrolysis. It catalyzes a hydrolysis reaction. So, hydrolysis is you use a water molecule in order to cause breakage. So, ano nangyayari dito? For example, an example of this is your maltase. So, you're in your maltase, di ba? Sabi natin, your maltose is two glucose molecules linked together by an alpha-1 bond. So, itong H2O mo, you put them in here. So, your H2O, your hydro, will cause the bond to break. So, yung isang H kakabit dito sa OH dito, yung other OH kakabit dito sa kabila. So, magiging ganito siya. It causes the breakage of your bond. So, yung mga disaccharidases natin, si maltase, lactase, sucrase, di ba puro sila, tawag doon, puro sila hydrolases. Next, you have other examples here, di ba? Your lipases, syempre, it hydrolyzes ester linkages in lipids. Your proteases catalyzes, syempre, amide linkages in proteins. Your nucleases will hydrolyze sugar phosphate ester bonds in nucleic acids, which we will discuss in our next lecture. Your carbohydrates, yung disaccharidases natin, for example, hydrolyzes glycosidic bonds. And then you have your phosphatases that catalyzes the hydrolysis of phosphate ester bonds. Okay? Next. You have your liases. So, ito namang liases, medyo bago to sa pandinig natin. So, your liases catalyzes the addition of a group to a double bond or a removal of a group to form a double bond in a manner that does not involve hydrolysis or oxidation. So, anong nangyayari dito? So, kailangan hindi siya hydrolysis, kailangan hindi siya oxidation. So, it catalyzes the addition of a group to a double bond. So, dito, for example, you have your fumarase. So, ano nangyari dito? You add the group to a certain, itong si H2O mo, you add this in this manner. You add this to this carbon, and then the other H, you put this to this carbon. So, ano nangyari? You remove you add groups to a double bond in order to remove the double bond. Or pwede rin, you remove a group in order to form a double bond. So, pwede siyang, pwede siyang formation of a double bond. Pwede siyang removal of a double bond. So, okay. So, for example, some of the liases, you have your dehydratases, your decarboxylases, your deaminases, and then your hydratases. So, makikita mo naman kapag syempre, that's removal. So, if you remove water, that's a dehydratase. If you remove a carbon dioxide, then that's a decarboxylase. If you remove an NH3, that's a deaminase. If you add naman, syempre, walang it's a hydratase. Dehydratase, removal. Hydratase, that's addition. Okay? So, yun lang. Tatandaan nyo yung mga certain examples dito. And kung anong class sila nagbe-belong. Okay? Next. So, you have your isomerases. So, your isomerases catalyzes the rearrangement or isomerization of a substrate in a reaction, converting it to a molecule isomeric with itself. So, there's only one product and there's only one reactant in this reaction. Compared mo dun sa oxidoreductase na kailangan meron ka coenzyme, di ba? Kasi kailangan partner siya. So, dito sa isomerase, isa lang yung product, isa lang yung reactant. So, for example here, you have your phosphoglyceromutase. So, itong mutase is one of the suffixes that will denote your enzyme as an isomerase. So, ano nangyari dito sa reaction na to? So, there is rearrangement of atoms. Di ba? You have a phosphate over here. You have a hydrogen over here. So, using your phosphoglyceromutase, yung phosphate mo, lilipat siya doon sa O on carbon number 2. And then, dito magiging H na lang yung nagiging dulo. Okay? So, ang nangyari is, nagpalit sila ng so yung functional group na to, you transfer it to another position in the same molecule. So, there are two examples of isomerases dito from our book, di ba? You have your racemases and your mutases. So, your mutases catalyzes the transfer of a functional group from one position to another in the same molecule. Next, you have your racemases naman. Your racemases catalyzes the conversion of your molecules from D isomer to L isomer. So, for example, meron kang monosaccharide. So, from D isomer, gagawin mo siyang L isomer. So, parang ganun lang nangyari doon sa dito sa sa reaction na to, no? Okay? So, papalitan mo lang yung right-handedness niya. In your racemases. In your mutases, there is a transfer of a functional group within the same molecule. Next. Doon tayo sa last class of enzymes. You have your ligases. So, ligase is catalyzes the bonding together of two molecules. So, meron kang linya dyan, meron kang sa mga linya dyan, for example. Then, what the ligase does is it connects them. Okay? So, for example, here in your example, you have your pyruvate carboxylase. This one is a pyruvate molecule, and then pyruvate carboxylase, magdadagdag ka na COO dito sa dulo niya. So, naging, you bond together, two molecules naging, this part is the pyruvate, this part is the CO2 to form your oxaloacetate. So, what are your ligases? What are examples of your ligases? You have your synthetases and carboxylases. Your synthetase, as the name implies, it catalyzes the formation of something. So it's used in the synthesis. So you synthesize something by bonding to different substrates, and usually your synthetase uses ATP. So there's a new bond between two substrates in order to form a new product. Next, you have your carboxylases. So your carboxylases, since nakalagay na sa pangalan niyan na merong carboxyl, so there is formation of a new bond between one substrate and the other one is CO2. So dito sa synthetase, pwedeng two different, meron kang substrate A plus substrate B. So it can be anything to form something that is AB, diba? Meanwhile, dito kay carboxylase, kailangan yung B mo is, in particular, is O2. Okay, so your ligases also, so your carboxylase along with your synthetase also utilize ATP. Okay? So itong ligase reactions kasi are generally energetically unfavorable. So they require input of energy obtained by hydrolysis of ATP. Okay. Kaya your synthetase and carboxylase usually they require participation of ATP. Okay? Next. Doon na tayo sa factors that affect enzyme activity. So what are the different factors that so yung enzyme activity, by the way, is the measure of the rate at which an enzyme converts your substrate to a product. So there are 4 different factors that we will be discussing, which is temperature, pH, substrate concentration, and enzyme concentration. So doon muna tayo sa temperature. So what is temperature? If you recall from your earlier your prerequisite subjects, diba? Temperature is a measure of kinetic energy of molecules. Mas mataas yung temperature, mas mabilis gumalaw yung mga molecules in the atmosphere. Kaya siya nagiging mas mainit. So pag mas mainit, pag mas mainit, syempre mas mabilis yung movement. So same way, if you have something in a reaction, pag mas mataas yung temperature, there will be a faster motion of molecules in that substance, and then there will be more collisions between substrates and enzymes. So, pag madalas silang mag-collide with each other, syempre, mas likely na magkaroon ng binding between substrate and enzyme. So, pag mas nag-bind sila, syempre, mas mabibilis yung reaction rate. And the temperature at which the enzyme exhibits maximum activity is what you call your optimum temperature. So, the temperature at which an enzyme exhibits maximum activity is your optimum temperature. So, doon na yung temperature na yun, yung pinaka-ideal temperature for the reaction to occur. Kasi yun na yung uh, uh, yun yung temperature at which the reaction is occurring the fastest. Kasi yun na yung optimum, di ba? So, gusto natin, mainit siya para mabilis mangyari yung reaction. Pero, not so hot that the enzymes will start to degrade due to denaturation. Diba? Sabi natin in our previous lecture regarding your amino acids, pwede silang yung mga peptide, mga proteins natin can denature kasi at a certain temperature, your heat can disrupt your secondary, tertiary, quaternary structures of your proteins. So when your temperature and your enzymes are proteins. So when temperature increases beyond the optimum temperature, denaturation will start to occur. So in humans, the usual optimum temperature is 37 degrees Celsius, diba? So kaya nga, yung core body temperature natin, normal natin is around 37 degrees Celsius. So, if yung tao, for example, meron siyang fever, yung fever na yun can lead to mag-start, pwede na, if your fever is so hot, if your fever is so high, for example, umabot ka na ng 40, more than 40, then that's already life-threatening. Kasi at 40, pwede nang mag-start, mag-denature yung mga enzymes mo. For example, meron kang enzymes in the brain na nag-start niyang mag-denature. Pwede na siyang pag nag-denature na yung enzymes mo in the brain, yun na. Kaya nga, di ba, ayaw natin yung mga bata na magkakaroon silang, aapuyin sila ng lagnat. Kasi pag nag-denature yung enzymes nila, for example, sabihin, doon na yung nag-seizure, etc. And once nangyari na yun, mas likely ka na magkaroon ng seizures in the future. Okay? Next. So, ito rin yung idea, di ba? By you use autoclave or yung mga yung mga sterilizing machines natin, they use heat kasi yung pag nature mo, yung enzymes ng mga bacteria, ng mga pathogens, then they will not be able to speed up their reactions anymore. So, hindi na sila magiging less or rather, hindi na sila magiging pathogenic. Okay? Next. Let's go to your pH. So, pH is another factor that can affect enzyme activity. Your pH can lead to changes on the charge of acidic and basic amino acids located on the active site, 'di ba? So, hindi naman surprising yung statement na 'to because, 'di ba yung sabi natin yung amino acids natin, yung meron siyang positive at meron siyang, ah, negative. So, usually, wala siyang charge, 'di ba? Pero yung mga meron tayong certain amino acids that are acidic and basic, siyempre depende sa pH, that can puwede siyang ma-protonate or puwede siyang ma-deprotonate. So at the pH, so changes in pH can also lead to denaturation and loss of catalytic activity, 'di ba? Sabi nga natin, pH is also one of the denaturing agents as mentioned in the previous lecture. So, siyempre meron din tayong tinatawag na optimum pH. So, yung optimum pH, siyempre the pH at which an enzyme exhibits maximum activity. So, the usual optimum pH is actually 7 to 7.5 in our body. Pero siyempre meron ding certain exceptions, 'di ba? Sa katawan natin, pepsin, the optimum pH is 2.0. Sa stomach natin, your pepsin is an enzyme that catalyzes, siya yung nagka-catalyze ng digestion sa stomach natin, 'di ba? So so it functions best at an enzyme at a pH of 2.0. So, 'di ba, kaya nga yung stomach natin, ang pH niya is, around that pH. So, at that pH, nagiging mas optimum yung performance ni pepsin and allows it to do protein digestion even faster. Next, on the other hand, you have an example is your trypsin, 'di ba? Si trypsin naman yung enzyme found in the small intestine. It functions best at a pH of 8.0 kasi 'di ba pagkalabas ng pagkain mo sa stomach, so acidic yun, what your pancreas does is dump a bunch of basic ah, secretions dun sa small intestine mo. Nagiging basic siya siyempre dahil acidic yung stomach, maglalabas siya ng basic secretions para hindi denature yung intestinal lining mo. So yung basic secretions from your pancreas, usually bicarb, ah, then kaya nagiging pH 8.0 yung kaya pH 8.0 or high pH yung optimum ng trypsin kasi it works during the digestion that occurs in the small intestine. So next, doon naman tayo sa tinatawag nating substrate concentration. So if you have a situation wherein the enzyme concentration is held constant and the substrate concentration is increased. So, yung enzyme mo pare-parehas lang pero dumadami yung reactants, then the reaction rate will increase until it reaches maximum reaction rate or maximum reaction velocity. So, bakit may limit? So as substrate concentration increases, enzymes become fully occupied. So enzymes become fully occupied, so magiging saturated na siya. When your enzymes are fully saturated, each incoming substrate must wait for an empty active site. So anong nangyayari dito? So for example, you have enzyme A, and then you have enzyme B, and then you have enzyme C. So meron kang substrate. Si substrate mo, ito. So kung tatlo lang sila, so syempre, tatlo lang yung substrate na pwedeng mag-bind. Pag dinamihan, so, kung constant yung amount of, uh, yung amount of enzymes mo, pag padami ng padami, syempre, pabilis ng reaction. Pero, at a certain point, pag masyado ng marami yung substrate mo, then, kailangan nilang antayin na matapos muna yung mga reactions that are occurring before they can bind. So, they have to wait for the substrates that are occupying the active sites of these enzymes to leave or to become converted into product before they can bind. So, kailangan nilang pumila, di ba? So, pag nakapila na sila, nagawa na nito yung mga ginagawa nila, then tsaka pa lang sila pwedeng makipine. So, kaya meron siyang, kaya it approaches a maximum reaction rate. So, before the reaction can occur. So, the rate in which the enzymes accepts substrate molecules and releases product molecules at substrate saturation is the turnover number. So the turnover number is the number of substrate molecules transformed per minute by one molecule of enzyme under optimum conditions. So here is, so doon na tayo sa last factor that affects your enzyme activity. You have your enzyme concentration. Dito naman, if constant yung substrate concentration mo and enzyme concentration is increased, therefore bibilis din yung reaction rate. So for example ulit, meron kang enzyme, and then you have your substrates. So yung substrates mo, so kung isa lang, then mabagal pa lang siya. Pag dalawa na sila nag-act, then bibilis yung reaction. Pag tatlo na, then it will become even faster. Pero pag dinamihan mo to, syempre, tapos yung substrates mo, then it will increase and increase as the more enzymes there are. So the increase and the concentration of the enzymes allow more substrate molecules to be accommodated. Diba? So kasi yung enzymes naman natin, hindi naman siya mako-consume. Hindi kagaya ng substrates na mako-consume. So yung enzymes natin, the greater the enzyme concentration, the greater the reaction rate. Okay? Next. So, review lang ng mga diniscuss natin. What are the mechanisms of enzyme action? Di ba meron tayo, no? Lock and key model wherein the active site is fixed and the only the substrate that fits into the matching shape of the enzyme's active site will be able to fit. Meanwhile, you have your induced fit model wherein the active site of the enzyme is actually a lot more flexible than you think. If the substrate is close enough, then the enzyme's active site will adjust and still allow the reaction to proceed. And then you also mentioned that there are 4 different factors that affect enzyme activity: pH, temperature, the substrate concentration, as well as the enzyme concentration. Okay?